Hello and welcome to another exam paper walkthrough. Today we have a fantastic set of predicted papers. So this is based on students having sat the paper one. We've taken, well not we, this company Maths Planner has taken off all of the topics that have already been seen and produced this as a predicted paper. It's kind of a best guess paper. It's a really nice paper. I've had quite a decent look through it. If you want to look and check out any of their resources, www.mathsplanner.com. Right, so we'll crack straight off with question one. Write down 0.316 as a fraction in its simplest form. So we're on a calculator paper. So first of all, this, if I was describing it, I would say it was 316 thousandths, which means I can write it as that fraction. So I'm going to start with 316 thousandths. Sorry, 116 thousandths. Sorry, I misspoke there. And then I'm going to use my calculator to simplify it for me. So I'll type it in just like that, 316 thousandths. That automatically cancels it down for me to 79 out of 250. So I didn't mention I'm using quite an old emulator here, the FX82. It's fit for purpose, but don't worry if you've got a much more modern version. Next one, write 3/8 as a percentage. So I'm going to use my calculator again. I'm going to do 3/8 times by 100. So type it in just like that, 3/8 times by 100, and that will give it me as a percentage. Obviously, if I wanted it as a decimal, I wouldn't have times it by 100. I would just have done 3 divided by 8. So I'm looking at 37.5 for that one. Right, question 2. Change 23,000 meters into kilometers. Well, I know that 1 kilometer is equal to 1,000 meters. So 230,000 meters is going to be equal to 23 kilometers. So 23 kilometers. Right, question 3. So first of all, we're simplifying. So we've got 3q squared plus 3q plus negative 5q squared. So I'm going to rewrite that, just replacing those two symbols with a negative symbol. So 3q squared plus 3q minus 5q squared. I'm going to write these in size order, although there's nothing wrong with you not writing it. So I'm going to write my q squareds first of all, even though it's negative. So 3 take away 5 is going to be minus 2q squared plus 3q. And there's nothing wrong with writing it as the q first, so 3q minus 2q squared. I just have a habit of writing my my q's in descending order, so I'll put my squareds before I put my q's. And part B, simplify. So all I'm doing here is dividing by 12. I can rely on my calculator if I need to. So I'm going to put it as 56 over 12x. And I'm going to use my calculator to simplify that down. I'm just trying to think. I don't think it goes in exactly. So I'm going to leave it as 14 x over 3. Right, question 4. Write the following numbers in descending order. So descending means starting with the largest, going down to the smallest. So the largest number here is the one that's closest to 0. I'm going to kind of in my head ignore the negatives, and I'm going to ignore the zeros and just pretend that I've got them all to 3 digits, and I'm going to write them smallest to largest and then convert them back. So the smallest number, or if I'm just viewing them as these numbers, the smallest number there is going to be 205, which is minus 0.205. My next smallest, I'm going to cross it out just so I don't get confused. And I've miswrote straight away. So my smallest one is 00. So my pen's stopped working. It will probably kick in a second and scribble all over the screen. So sorry, my smallest is 005. And what caused me the issue there is I misspoke. So I should have added made them all 4-digit. So my next smallest one is going to be this one, 2010, which started life as minus 0.201. My next smallest one then is going to be this one here, so minus 0.205. My next smallest, or next largest technically, but I'm just looking at the digits at the moment, is going to be this one. So that's minus 0.215, leaving me with minus 0.22 as my final number, and it's not letting me write there, so I'm going to just write it underneath. And because I was viewing them as the digits rather than the whole numbers, and I'm asked to do them in descending order, that is in descending order. Technically, this is the largest going down to the smallest because we've got negative numbers. Okay, so the median. So when in size order, the median is going to be the middle number. So the median is going to be, let's just change pen to show this. So this number is going to be my median when in size order. So I'm looking at minus 0.205. And question 5. In a theatre there are X rows of seats and each row holds Y seats. So in effect we're kind of viewing it like this. So this is a theatre and we've got X number of rows and we've got Y number of seats. Write an expression in terms of X and Y for the maximum capacity of the theatre. That's kind of going to be the area. So we'd work that out as X times by Y. So XY or YX. Okay, question 6 then. John and his brother are looking to buy a new gaming computer that costs £2,400. Wow. The store requires a deposit of 20% of the total cost up front and allows them to spread the remaining costs over 10 months with equal monthly payments. John and his brother agree to share the deposit in the ratio of 2 to 3, and John will pay 3/5 of the remaining monthly payments. Work out how much John's deposit and his brother's monthly payments are. Okay, so key bits of information then. We've got our total, we've got our deposit of 20%, and then we've got 10 months of equal payments, and then we've got our ratios. So the first piece of information that I'm going to look at is the deposit. So if I'm looking at the deposit, I want 20% of 2,400. So I'm going to do that by doing 2,400 multiplied by 20%, or 0.2 as a multiplier. I'm also at the same time going to work out what 80% would be, because that would be the remaining balance, by doing times by 0.8, just because very similar calculation on my calculator, so I can save myself a little bit of time. So that's going to be the deposit. And then just use my replay, change it to 8, and that's going to be my remaining balance. So 1,920, which is the remaining. Okay, so I'm first of all working out John's deposit. So if this is my ratio, so I've got John and his brother, so I'm going to call them J and B. So if their ratio is 2 to 3, and I'm in effect, that means that that's 2/5 and 3/5. So John's deposit is going to be 2/5 times by 480. So 480 times by 2/5. So that's going to be 192. And that's one of the two things I was asked to work out. And the other one is brother's monthly payment. So brother's monthly payment is going to be 2/5 again. It's going to be 2/5 of, so again 2/5 times by this value, the remaining, divided by 10. So I'm going to cancel the zeros off straight away and then just change this to actually 192 is my last answer. So the brothers' monthly payment will be £76.8. Okay, so John's deposit is 192, and then brothers' monthly payment is 76.80. Just to put it in pounds and pence. Let's just clear up my pound signs, make them a little bit better. Question 7. ABCD is a trapezium. Calculate the size of the largest angle. Okay, so I actually want the size of this angle. But this angle and this angle are what are called supplementary or co-interior angles. So they're going to add up to 180 because we've got parallel lines here. There we go. Correct my notation slightly. So I'm going to say that 4 lots of 2y minus 1 plus 3y, 30 minus y is going to be equal to 180. So multiplying that out, that would give me 8y. Take away y would give me 7y. And that's going to be minus 4 plus 20 is going to be plus 26. And that's got to be equal to 180. So I'm going to minus 26 from both sides, and that will give me 7y is equal to 154. So double check all my calculations. Very common dropping a mark because I'll do something in my head quickly and not rely on my calculator. Divide that answer by 7. So I get, dividing both sides by 7, I get y is equal to 22. Now that's not technically the answer. We were asked to work out the largest angle. So the largest angle was 4 lots of 2y minus 1. So that's going to be 4 times by 2 times by 22 minus 1. Again, we can type it in like that on our calculator. 2 times by 22 minus 1. Close my bracket, and I get 172 for my largest angle. So 172 degrees. Question 8. Connor has 8 gold coins and 15 silver coins. Write the ratio of silver to gold. So interesting. In the ratio 1 to n. So the wording of this question is designed to try and catch you if you're not reading it very clearly. Even dyslexic, I will often get this the wrong way around. So we're told the ratio is silver to gold, and we want it in the form 1 to n. But we've got 8 gold coins to 15 silver coins. So I'm going to divide both sides by 15. So in effect, that would, let's just move this down a little bit. So I want it in the form 1 to divide both sides by 15. I'd get 8 over 15. It doesn't ask for a decimal, so 8 out of 15 is absolutely fine. If you've gone decimal though, 8 divided by 15 is going to divide twice. Is going to give you 0.333333 reoccurring. So it's definitely useful to stick in the form, the fraction form. Question 9, we expand and simplify. So I'll go over the common 2 methods for the expanding. So the first one is using a grid method, so splitting the 2x and 1 into separate parts, and splitting the 3 and the x into separate parts. And we create a little grid out of that. So 3 times by 2x would give us 6x, 3 times by 1 would give us 3. 2x times by x would give us 2x squared, and then x times by 1 would give us x. We would then add these 4 terms together, but I'm going to kind of go, so I'll call that m1. and I'll just go that far just because it's going to be the same final step for both. So I'm going to do my second method. I tend to use this construction line method, but whichever one works for you is absolutely fine. So 2x times by 3 would give us 6x. 2x times by x would give us 2x squared. 1 times by 3 would give us 3, and then 1 times by x would give us x, and then we add, either way, we're adding these 4 terms together. We've got the same 4 terms. So again, I'm going to put my numbers in size, not my numbers, my terms in size order. So I'm going to go 2x squared, and then 6x plus 1x is 7x plus 3. And then my next one is factorize. So I'm looking for the highest common factor of 21 x squared y to the power 4 minus 56yx squared. So the lowest common multiple of 21 and 56 is 7. So I'll take 7 out as a common factor. I've also got an x squared common to both parts, even though they're written in a different order here. Very clever writing of the question. Hopefully it won't have caught you though. And then I've also got a y common to both parts. So that's my highest common factor. And then what do I need to times my highest common factor by to get each of the terms, each of the parts? So 7 would need to be times by 3. X squared needs to be times by 1 to get x squared. And then y would need to be times by y cubed to get y to the power 4. I've got a negative in the middle, and then 7 would need to be times by 8. Y would need to be times by 1, and x squared would need to be times by 1. So that is my fully factorized version. Right, question 1. Lucy is planning to go to a concert that starts at 8:15. She takes 35 minutes to get ready and leave her house. The walk to the bus stop takes 15 minutes, and then she has to wait up to 12 minutes for a bus. The bus ride to the concert takes exactly 42 minutes. She also wants to meet her friend at a restaurant near the venue for 1 hour and 1.25 hours before the concert. What is the latest time Lucy can start getting ready to make it to the restaurant on time? Okay, so in effect, I'm going to kind of walk backwards from this. So if we want to get to the restaurant at the concert at 8:15, so I'm going to say that's C on my journey. And then work backwards. So she wants to have a meal which lasts for 1 hour and 1.25 hours. So 0.25 of an hour. Realistically, we want to convert that into minutes. So if we do 0.25 times by 60, that will tell us we're looking at 15 minutes. We want to go back 1 hour and 15 minutes. So 15 minutes would take us to 8, and then 1 hour would take us to 7 o'clock. I'm going to write that at 7:00. We've then got the bus ride at 42 minutes. So 7 o'clock, take away 42 minutes, will take us to 6:18 p.m. So that's covered that. And then if I add these two together, the wait for the bus and the walk to the bus stop will take a maximum of those two added together, which is going to be 27 minutes. So if I take away 18, that would take us to 6, and then I need to take another sorry, I was just looking ahead. So if I take off 18 minutes, that would take me to 6 o'clock. I then need to take a further 9 minutes off, so that's going to take me to 5:51. So that's the time she needs to have finished getting ready. So I need to take off 35 minutes from that. which is going to be 51 take away 35. It's going to take me to, well, if I take off 40 and then add on 5, that would take me to 515. Which is an absolutely fine way of doing it. I will show you a second, and I've done that slightly wrong. I said take off 40 and then add on 5, that would be 16. So 516 is what I believe without calculator. I'm now going to do a version where I just add these times together. So I'm going to use my time function on my calculator, which is this button here, to add up these times. So I've got 0 hours and 35 minutes plus 0 hours and 27 minutes plus 42 minutes, so 0 hours and 42 minutes plus, and this was 1 hour and 15 minutes, so that's 1 hour and 15 minutes. So if I add those and type that in correctly, there we go, I missed off my first 0. And my 0 there as well. There we go. So my total time to get ready is, the total time of my journey is 2 hours and 59 minutes. So if I do 8 hours and 15 minutes minus the answer that I just worked out, that will give me 5 hours and 16, so 5:16, which is what I found it to be. And that's just a version I could have used. Good to check. Not very often used though, the time function on your calculators. Probably if you're not used to it, don't bother, because it's more than capable with a bit of steps. Okay, question 11. This compound, so compound made up of a number of other shapes, is made from 3 congruent parallelograms. The area of the compound shape is 88.2. Calculate the value of H. Okay, so for this, I'm going to straight away switch to working out the area of one of them. So I'm going to do 88.2 divided by 3. So the area of each parallelogram is going to be 88.2 divided by 3. And I'm going to leave it as that, 147 over 5. So that's the area of one of them, 147 over 5. Now the area of a parallelogram is base times height. We've got a base length of 7 and the height is what we don't know. So in effect, I'm going to write 7h, 7 times h is going to be equal to 147 over 5. So h is going to be equal to, divide both sides by 7. That's going to give us 21 over 5. And if I want that as a decimal, it's going to be 4.2. But 21 divided by 5 is 4.2. Right, question 12 then. So for question 12, this table shows Mr. Andrews' Year 10 GCSE Paper 1 mock results. So we've got 0 to 20, so we've got groups. It looks like they're all even groups. Write down the modal interval of the scores. So the modal interval is the one that happens the most. So even though we call it modal interval, that's a way of describing scores. So the modal interval is the group that the mode appears in. So we're looking at 20 is less than m, which is less than or equal to 40. Okay, work out an estimate for the mean number of marks in Mr. Andrews' class achieved. So for this, I need to pick up midpoints. So I'll do it up here just to show what the midpoints are. 20, 30, that's the middle of each of these groups. 50 and 70, these are quite nice ones to work out, but if you're ever unsure how to work out the midpoints, add the two numbers together and divide by 2. So as a working example, 20 plus 40 equals 60 divided by 2. That's my midpoint. Right, I need to add up the midpoints times by the frequency. So I'm going to do 10 times by 8 plus 30 times by 15 plus 50 times by 8 plus 70 times by 4, and I need to divide that by the total frequency. So the total frequency, which is going to be 8 plus 8 is 16, plus 15 is 31, 35. So divided by 35. Right, so I'm going to type it into my calculator like that. I've shown what I'm typing in, and then I can use my calculator to type that in. Always need to double check that I've typed it incorrectly though. These emulators are a little bit fiddly, sometimes cut out. Divided by 35, so double check that I've typed everything in correctly. So 70 times 4, check, 30 times 15, there we go. I just thought that I'd seen a mistake there. Maybe not. No, that looks fine. So when I press equals, that will give me my value. So I make it 242 over 7. We're asked for it as a decimal, though, to 1 decimal place. So I'm going to go far more detailed than I need to. And then I'm going to round it. So 34.571 ... to imply that I've not rounded. So to 1 decimal place, that's going to be 34.6. Why is your answer to part B an estimate? Well, it's an estimate because what we did was we took the middle value for each of these groups. So that's why it's an estimate. We took, this is where I embarrass myself, we took the midpoints to represent each group, which makes it an estimate. Okay, so that, I believe, we took the midpoints to represent each group, which makes it an estimate. So apologies if you can't read that. I've not got great handwriting. Okay, question 13, transformations. So I don't really need my calculator for this. So rotate triangle T 270 degrees clockwise about the origin. Label your new triangle A. So I'm going to replace that by a 90-degree anti-clockwise. Just because that's easier for me to view. And then I would strongly recommend using tracing paper if that's going to help you, or at least use tracing paper to check. I tend to kind of view it as my movement. So if this was 1 to the right and 2 up, it's going to go 1 up and 2 to the left. So that position is going to move to there. And then from there, I'm going to do my do my rotation. So my orientation's changed to that there, and label it A. And then it says part B, translate the vector A by the vector, translate triangle A by vector 3 minus 5. So if I pick a point to move, so I'm going to look at the movement from this point here. So if that was going to move 3 across and 5 down, so 3 across and then 5 down. So that point alone will move to there, and then I just redraw my triangle from there. And label that triangle B. And question 14, use your calculator to work out square root of sine. So I'm obviously going to need my calculator for this. And I'm just going to type it in exactly as it appears. So fraction button, square root, and in the bracket I'm going to, sorry, not in the bracket, into the square root, I'm going to write sine 30, close bracket, plus 2.01 to the power 4. And then my denominator becomes, so use my replay buttons to move to the denominator, open bracket 6.7 minus 3.2, close bracket, and I want that to the power of a half. So I could put 0.5, but I'm going to actually put it in as a fraction, just to show that the calculator can do that, and I can type it in exactly as it appears. Double check what I've typed in. So sine 30 plus 2.01 to the power 4. The square root is only acting on the numerator, divided by 6.7 minus 3.2. I missed the 0 out, but that's not going to affect my answer. I'll put it in anyway though. And then equals, and then my value is going to be 2.19. So it says to write down all the values. So I'm looking 2.192350859. And then round your answer to part A to two significant figures. So to two significant figures, that's going to be 2.2. So it's the 2 digit that I'm rounding to. The number behind it's a 9, so it goes up. Question 15. A bag contains only red counters, blue counters, green and yellow counters. A counter is taken at random. The table shows the probability of taking a counter from the bag. So we've got two of the probabilities missing. The probability of taking a blue counter is 4 times greater than the probability of taking a green counter. So if I call the probability of green x for now, and then that one's going to be 4x. Complete the table. So I probably shouldn't have put that there and there. That's x and 4x there. Right, so all those probabilities need to add up to 1. So if I add them all together, my number, so I'm going to have 4x plus 1x is going to be 5x, and then 0.15 plus 0.2 is going to be 0.35, and that's got to be equal to 1. So 5x has got to be equal to 1 minus 0.35 is going to be 0.65. And then if I divide that by 5, that's going to be x is equal to 0.13. Let's just double check those calculations. 1 minus 0.35 gives us 0.65, and then divide that by 5 gives us 0.13, meaning that my other probability is going to be 4 times that, so 0.52. So that's my completing of the table. Part B. Work out the number of blue counters in the bag. So if there are 50 yellow counters, so we need yellow and blue. So if I go yellow and blue, so we've got probabilities of 0.2 and 0.52, and we're told that we've got 50 yellow counters. Well, to get from there to there, I would need to do 0.52 divided by 0.2, so I'm timesing by that, so I'm timesing by 2.6 there. So if I times by 2.6 there, that would give me 50 times by, that would give me 130. So 130 blue counters. Okay, question 16. Jackie decides to cycle to her friend's house. She lives 18 miles away. Jackie estimates that her average cycling speed is 12 miles per hour. How many minutes should it take Jackie? Speed is equal to distance divided by time, or if you use the triangle, speed is equal to distance and time. Oops. So I want time this time, so I can either rearrange this by multiplying by t and dividing by s, or I can use this. Time is going to be equal to distance divided by speed. So for this, it's going to be 18 divided by 12, which is going to be 1.5, and that's going to be in hours, because this unit here is hours. So double check. Yep. So number of minutes then, that's an hour and a half, so that's going to be 90 minutes. A sudden increase in wind speed reduces her average cycling speed to 90 by 20%. If she needs to be at her friend's house by 12:45 and leaves at 11, will she make it on time considering the wind effect? So the wind effect, if we go the adjustment to her time then, so our distance is going to stay the same. So our distance is going to stay the same, but our time, if we're reduced by 20%, that's the same as multiplying by 0.8. So it's going to be divided by 12 times by 0.8. So the effect on our time is going to be, our new time is going to be 1.875 hours. So that's 1 hour and 52 minutes and 30 seconds. So 1 hour, 52 minutes and 30 seconds. So if we add that to 11, so plus 11 hours gives us, and then if we, so she will, so if she set off at 11, she would get her at her friend's house at 12:52 and 30 seconds. So I'm going to rewrite that. It doesn't make sense to do it that way in time. Well, 12:52 and 30 seconds to be precise. So, does she make it on to her friend's house on time? No, she wouldn't. Question 17. The first 5 terms of an arithmetic sequence are, and we've got them there. Write down the next 2 terms in the sequence. So we've got our sequence, our difference between our terms. We're going down by 0.8 each time. So my next term is going to be minus 1.8 minus 0.8. So my next term is going to be, as a decimal, minus 2.6. And my next term is going to be minus 0.8. Is going to be minus 3.4. Write an expression in terms of n for the nth term of the sequence. So this 0.8 means that my sequence must start with a minus 0.8n. And then I need to think, what do I need to do to minus 0.8 to get to the first term in the sequence? And that would be add 2.2. So minus 0.8n plus 2.2. Right, question 18. So AB, so we've got 2 triangles placed together. We're told AB is 10.4. So I'll add that to my diagram. And we're told that the angle is 34 degrees. And we're told the ratio of AB, so that's that length, to AD, that's that length, is the ratio of A to B, and A to D is the ratio 4 to 5. Give your answer of C, find out the value of CD, so I'm going to call that X for now. Giving your answer to 2 decimal places. So a bit of forward planning here. I'm going to use my ratios to work out this length here, and then from there I'm going to use Pythagoras to work out that length there, so I'll call that Y. So first thing I'm going to work out is AD. So if that is 10.4, then this length is going to be, well, what do I need to times 4 by to get there? So 10.4 divided by 4 is going to be equal to 2.6. So I've times by 2.6 here. If I times by 2.6 here, that will give me 5 times by that answer 13. So my missing length is 13. So I'll add that to my diagram now. So y is going to be equal to the square root of 13 squared minus 10.4 squared, which is going to give me 13 squared minus 10.4 squared, and that's going to give me 39 over 5, or 7.8. Okay, now I'm going to use, I'll change my pen colour again to show my different stage of working. We'll go darker green. So I'm going to be using trigonometry now to find the hypotenuse using the opposite and the angle. So I'm going to use the sine ratio. So sine is equal to opposite over hypotenuse, and it's the hypotenuse that I'm trying to work out. So h is going to be equal to the opposite side divided by s. So x is going to be equal to 7.8 divided by sine of 34. So I want my last answer divided by sine of 34. So we've got 13. So x is going to be equal to 13.9486 ... So to 2 decimal places, I'm rounding to that figure there. The number behind it is an 8, so I'm going 13.95. Have I got a unit here? We're in centimetres. Okay, question 19. Write 1,700 as a product of its prime factors. So I tend to normally take 2 out as a common factor, but I know that 17 is a prime number, so I'm going to go 17 times by 100. And then I'm going to go 2 and 50, 2 and 25, 5 and 5. So as a product of its prime factors, I'm multiplying these together. So I would have 2 squared times by 5 squared times by 17. Okay, find the highest common factor of A and 1,700. So these are common factors. Highest common factor, we've got 2's in common. We've actually got 2 squared in common. They've also got 5 in common. Actually, I'm writing that in the wrong place. So we've got 2 squared in common, and we've got a 5 in common. So that will be my highest common factor. So 4 times by 5, so we're looking at 20. Right, question 20. During a housing market crash, the price depreciates by 2% per quarter in the first year and 1.5 per quarter in the second year. Henry's house was valued at $465,000 at the start of the crash. How much is Henry's house worth 18 months into the crash? Give your answer to the nearest pound. So let's start by saying that 2% depreciation, so 2% reduction is going to be a multiplier of 0.98, and then a 1.5% reduction is going to be a multiplier of 0.985. So we want 4 lots for a full year. Quarter means quarter of a year, so we want 4 lots of this one. And then in 18 months, that's 12 months plus another 6 months, so another 2 quarters, so 2 quarters of that. So I'm going to do 465,000 multiplied by 0.98 to the power 4 times by 0.985 to the power 2. So that's going to give me 465,000 multiplied by 0.98 to the power 4 times by 0.985 squared. So that's going to be my total. So I'm going to write all figures, well, not all figures, further than I need down, and then I'm going to round. Actually, all figures down. To the nearest pound then, that's going to be 416,131. And that brings us to the end of the paper. So really nice paper. Really enjoyed doing that. Thank you very much to Maths Planner. Fantastic. I thought it was very challenging, particularly the last few questions on the foundation. But I think that's great in terms of a predicted practice best guess paper. Very good paper. So please bear in mind, if you found any of those questions particularly challenging, these are the topics. So for your independent revision, I would recommend you focus on those particular aspects. Again, shout out to www.mathsplanner.com. Copies of the paper can be found there. Thank you very much for taking the time to watch the video. I hope you found it useful. Feel free to add any comments or suggestions into the chat, and I'll get back to you as soon as I can. Thank you very much.